Here we go. We are starting right now. And what we're going to do is we're going to go through a few problems that you guys will see on tomorrow's assessment. Not only the problems that you guys did right here, but also a couple that I added onto it. And you can try to write them down with me, or what you can do is just go back and watch the video on them tonight and record them then.
Are we able to use this for our test?
Yes, absolutely. Okay, all right, so here we go. First problem says this. Anna is on a road trip. She uses 3/4 of a tank of gas every 9/2 of an hour. How many tanks of gas will she use after 12 hours? Did anybody get an answer? What did you get?
I got 2 tanks.
You got 2 tanks? All right, did anybody get something different? Okay, all right. What did you get that was different?
6 tanks.
6 tanks, all right. Okay, anybody get something different than 2 or 6 tanks of gas?
I got 3 and 5 tanks.
Okay, all right, so here we go. In order to solve this problem, the first thing we want to do is we want to find out how many tanks of gas she uses for 1 hour. So we're going to set it up for tanks of gas 2 hours. Okay, see how I set that ratio up? Okay, all right, so hold on, ready? So we know that right here in the problem, she uses 3/4 tanks of gas. So 3/4 is going to go here. Oh, sorry.
Button on the thing. The button.
There, thank you. Sorry about that. Okay, 3/4 tanks for every 9/2 of an hour, right? Now, if I asked you to find the unit rate for anything, what operation would you do to get the unit rate? You would? Divide. So we're going to go 3 ABC4 divided by 9 ABC2. So that's 3/4 divided by 9/2, and it comes out to be 1/6 of a tank. Hold on, we're not done. For every 1 hour. But the problem wants us to find out how many tanks of gas she needs in 12 hours. So in order to figure that out, that's why we would take 1/6 and multiply it by 12. So 1/6 times 12 comes out to be 2. So she needs 2 tanks of gas for 12 hours of, I'm assuming she's driving. Okay? Okay? All right. Next. So if you guys got that wrong, you probably want to write it down. Okay? All right. So if you have questions or comments about that, wait until I'm done with this whole thing, okay? Next, number 2. A water leaks through a roof and collects in a bucket. The table shows how many cups of water collect in the buckets for a different number of hours. What is the constant of proportionality? Hold on. This is the important part, and this is where a lot of people made a mistake when they've already done that. For hours to cups of water. That is important that you know how to set it up. So it's hours to cups of water. So with that being said, we're going to set it up how it's written. Put your hands down for right now. Okay, so my hours, I'm going to just pick one of these to use. I can use that one. I can use that one. Does it matter? No. They're all the same. So 2/6. Now, how do you guys find the constant of proportionality? You would? Right, we would divide. So 2 divided by 6 comes out to be, 0.3 repeating? But there's no decimals over here. So another way is you could take this and look at this as a fraction, right? 2/6 reduces down to 1/3, right? Which, that is a fraction here. But you could also, if you choose not to go through that, you could go through deductive reasoning, right? Well, this is a decimal. Decimals are fractions. Well, this is a fraction, but to change this into a decimal, I divide. Pay attention, please. 1 divided by 6, that's not 0.3 repeating, so it can't be A. C is a whole number, but this is not a whole number. This is a decimal, so it cannot be C. B is 1/3. 1/3 as a decimal, 1 divided by 3, bingo. There it is. So our answer is 1/3. Okay? All right. Okay? Okay, here we go. Number 3. Shh. Number 3. The graph shows a proportional relationship between the amount of money Tess earns and the hours she works. Okay, so watch. Let's go over to our graph. We already know it's proportional because it tells us that, right? Our x-axis goes with what?
Y-axis.
Now, our x-axis is labeled in what? Hours. Our y-axis is labeled in money earned, right? So, eyes up here right now. Eyes. Pay attention. The 0.1 comma 12.5 means that Tessa makes $1 in 12.5 hours. Well, if you guys remember, this is an ordered pair. The first number, remember my ABC, A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y. So in an ordered pair, the first coordinate comes from your x-axis. The second coordinate comes from your y-axis. And I'm going to tell you guys right now, half of you are not paying attention. I see what you're doing. Okay? I am doing this to help you be prepared. Please pay attention. Okay? So, this is your 1 on your x-axis, but 1 represents what?
Hours.
Hours. But this says 1 is money.
No.
So this is not correct. B, the 12.5 identifies the constant of proportionality. Remember, the constant of proportionality is like the unit rate. Just like when we did the unit rate up here, my denominator was what? 1, right? And so, if you look at this, this is your x value, this is your y value. To find your constant, remember it's y divided by x. So 12.5 over 1. So that is true. And if you guys remember what we already talked about, when x is 1, I go up to my line and then I go over, and whatever this number is right here is my unit rate. So this is true. C, 0.00 means that the constant is 0. That is false. 0.00 is this point right here, and what that point means is that for $0 for 0 hours. So you don't earn any money if you don't, babysit or work 0 hours. And last but not least, 0.5 comma 6.25 means that Tess earns $6.25 every half hour. I don't even really have to look at my chart, even though I can. Here's 0.5, and that must be 6.25. But this is my x value, this is my y value. So half an hour is $6.25. Yes, that is true. Okay? Comments, questions, or concerns so far? All right, here we go then. We're not doing number 4, we're skipping to number 5. Okay, did anybody get an answer for number 5 that they want to share with us? What'd you get?
254.34 feet.
Okay, all right, did anybody get a different answer than 254 and what was it? 3,400 feet squared? Nobody got a different answer than that? Yes?
81 pi.
81 pi? Okay, all right, so here we go. A circular rug has a diameter of 18 feet. What is the area of the rug? Who can tell me what is the formula to find area? Go ahead.
8 equals pi r squared.
All right, cool. But here's the problem. In the problem, they don't give us the radius. They gave us the...
Diameter.
So our diameter is 18. Therefore, what would my radius be? Okay, all right, so now watch. Oh, and this is where it gotcha. Look at what it says. It says use 3.14 for pi. So we're going to take pi out and we're going to plug in 3.14. And our radius is 9 and we're going to square it. So you are right. This would be 81 pi, but we have to use 3.14 for it. So 3.14 times 9 squared, which is 9 times 9, comes out to be 254 and 34 hundredths. Very important. This is your only warning. You must label. If you do not label, you will not get full credit. Because I don't know if 254 and 34 hundredths is chickens, right? So you have to label it. All right? Question? I don't know. Maybe it's part of the beak. I'm not sure. Okay. All right. Did anybody get an equation for number 6? What'd you get?
C equals 75.75.
Okay. All right. Anybody else get a different answer or the same answer than that? All right. You ready? Here we go. First step. You guys should remember this. All equations are written like this, where it's y equals k, but k represents the constant times x. But y, hold on just a minute, y is probably going to be a variable, and x will be the other variable. Sit up, pay attention. Thank you. All right, so now, first step, we got to find the constant. How do we find, you're zoning, don't zone, come on, back on track. How do you find the constant? What do you do? What? Okay, what do we divide?
227.25 divided by 3.
All right, we're going to divide the money by windows. And when you do that, you find out that it's $75.75 for every one window. So our cost, C, equals $75.75 for every window. There's your equation. Okay, and if you don't know that right off the top of your head, you know that the cost comes from, the cost is the constant, which was $75.75 per window. So if you can write that out in words, then just substitute C for cost and W for window and plug it in. I'm going to skip number 7 for right now because there's another problem that I did that's like it. All right, so flip over your paper. You guys can write this down with me. You guys can write this down or just pay attention and go back and watch it on the video later on your own time. Okay, you will have a problem that looks just like this tomorrow. Okay, so there's going to be a story problem that goes about it, and they're going to set up this ratio. This ratio is actually going to be written like this. This is really 2/3 divided by 1/2. Might help if it's not so blurry. Okay? So this ratio is written like this as a division problem. But we don't divide fractions. Instead, we keep, change, flip. So we keep the first number the same, change division to multiplication, and flip the next fraction into its, and when I say flip, what that means is we do the reciprocal of that fraction. Okay? All right? Now, we just multiply it out. What's 2 times 2?
4.
What's 3 times 1?
3.
4/3 is really 1 1/3.
So that's your answer?
That's my answer.
That's easy.
Easy for some, hard for others. So make sure that you guys have this. The next problem is where we definitely get tricky. Okay, here we go.
Oh, no.
You guys, this is something new. It's just like what we've been doing, but it's adding a step, so you need to watch. Mason has a recipe for salad dressing. It calls for 1/3 cups of olive oil, 1/2 cup of vinegar, and 1 2/3 cups of avocado. How much vinegar does Mason need for 6 cups of salad dressing? Well, it's up to you on if you guys, again, you can either write this down with me or you can just go back and watch the video tonight, your choice. But here's the scoop. You will pay attention to this. You will not talk. You will not fiddle around. You will not zone out. You've got to watch this. The very first step in order to solve this problem is we need to find out how many cups this recipe actually originally makes. So the first step we're going to do is we're going to add up all of these parts of our recipe. So 1/3 plus 1/2 plus 1 2/3. Okay? And again, I'm not grading you on if you can add fractions today. I'm seeing if you can find out how many cups of vinegar we need for 6 cups. So here we go. 1 ABC 3. I don't understand. What? Well, right now, just watch me go through this, okay? And then I'll leave it up there for you can write it down. So 1 ABC 3 plus 1 ABC 2 plus 1 ABC 2 ABC 3. So this comes out to be a total of 2.5 cups. So that recipe alone makes 2.5 cups of salad dressing. Okay? Are you with me so far on what I've done? Next, remember, I am only focusing on my vinegar. I'm only focusing on my vinegar. So the first step I want to do is I want to find out how many cups of vinegar I make with 1 cup of salad dressing. So the second step is I'm going to do 1/2 divided by the total cups of salad dressing. This came from my vinegar, right? And this is my total cups here. So what I'm going to do now is I'm going to find out how many cups of vinegar in 1 cup of salad dressing. How do I find the unit rate?
Divide.
So 1/2 divided by 2 and 1/2. And it comes out to be 1/5 cups of vinegar for 1 cup of dressing. Okay? All right, so So again, let me tell you what we've done so far. We found out how many cups this recipe makes. Then we found the unit rate of how many cups I need for 1 cup of salad dressing. Because now what am I going to do? What's my question asking me to find?
How much vinegar do you need for 6 cups?
Yeah, how many cups of vinegar I need for 6 cups of salad dressing. So what do I do to 1/5? Multiply it by 6. So 1/5 times 6 comes out to be 6/5, which is 1 1/5 cups of vinegar. Okay, that is definitely a multiple step problem. Okay, all right, and this part right here, you guys have been doing these kind of problems a lot, but it was the first step that was kind of added to this whole process. Okay? Questions? All right. Next problem. A wheelbarrow has a wheel with a diameter of 8 inches. How far will it move after 10 rotations? So here's my wheelbarrow wheel, and it's got a diameter of 8 inches. How far will it travel? So this is one rotation right here. 2, 3, 4, 5, 6, 7, 8, 9, 10. So what do I first need to find? What? It's, sorry. Okay, all right. What do I need to find for this circle?
Radius.
No, you guys are just, those are components. Okay, I need to find the circumference because the circumference is the distance around the circle. And if you think about a wheel, when the wheel on the bus go round and round, right? If it goes around and round, that's the distance. So who can remind me, what is the formula to find circumference of a circle? Okay, what?
R times C. Oh wait, no, R times D.
Not quite.
C equals R, D times R squared.
Hey. Nicole?
Equals D times pi.
Aha. Circumference equals diameter times pi. If you guys don't have a cheat sheet on that, I strongly recommend that you find one. Okay, so my diameter is already given to me. It's 8 inches. And we're going to go ahead, even though it doesn't say it, I'm going to use 3.14 for pi. Okay, all right, so 8 times 3.14 comes out to be 25 and 12 hundredths of an inch. Is that my answer?
No.
No, because this is only for one rotation. How many rotations does it go?
10.
So I'm going to take 25 and 12 hundredths and multiply it by 10.
251.2.
All right, and that is my answer. Okay? Sorry. So do you understand? You guys need to, tonight, go through and make sure you have the formulas written down somewhere. I know they're in your math books because I made you write them down, but you need to make sure you also have that little cheat sheet that we wrote on.
I'm not sure if we're available tonight.
Okay, okay, all right. Tomorrow morning works just fine. On the bus, wrestlers, if you guys are going to Acosta tonight, and if you have a smartphone, it's a 45-minute ride out there. You can watch it then. Okay, next question. Shh. The ratio of 5/8 to 10/9 has a unit rate of 9/16, true or false? Look, this right here is a way to write a ratio. Another way to write this same ratio is like this. So we would go 5 ABC 8 divided by 10 ABC 9, and it comes out to be 9/16. So that would be true. Again, you guys are the ones that are taking this tomorrow. I'm providing you good information. Okay? If you guys choose to use it, it's up to you. All right. Next problem. Joe is making a scale drawing of his house. The scale from his actual house to the drawing is 8 feet to 1 inch. The dimensions of his house are 96 feet by 160 feet. What are the dimensions on his scale drawing? What have I always told you about scale drawings? What do I recommend that you do? You always should start by?
Write the formula.
There's no formula to this.
Multiply.
How about we draw it out? Okay? So this right here is his actual house. And the actual dimensions are 96 feet by 160 feet. What is our scale factor? What is our scale factor? What's it say our scale factor is? What's our scale factor?
8.
For every 8 feet is 1 inch, right?
Yeah.
So our scale factor is just plain old 8. Now, we're going from the actual down to the drawing. So what do I do with my scale factor?
Multiply it.
Divide.
Oh wait, no, yeah, divide.
Because watch, here's what this says. For every 8 feet on here is 1 inch on here. I's up here on the board. So I am going to divide by my scale factor. So 96 divided by 8 comes out to be 12. So this side length is 12 inches. And then 160 divided by 8 comes out to be 20. So this is 20 inches. Okay? Okay, remember, when you go from actual to the drawing, you divide by the scale factor. When you go from a drawing to the actual, that's when you multiply. Again, you have these notes in your math book. Okay? The last one that I'm going to go through is redrawing a scale drawing. And we kind of struggled with this on our quiz. So, number 6 on page 29 is a good reference, but I'm going to show you kind of an example of one right here. I have this right here. Okay, this right here is a drawing. And it's got this side lengths 2, 2, 2, 2, 4, and 4. Okay? The actual perimeter of this same drawing is 64, I don't know, we'll call it feet. Okay? 64 feet. I want to draw a new scale drawing of this that has a scale factor of 2 feet to 1 inch. So the very first thing, we are going to go from our drawing, oh, you can't see that, just a minute. From the drawing, yep, to our actual size of the building, to our new drawing. That's what we have to do. Now, here's what I know. The only thing I know, to convert this drawing to my actual, I know that my actual perimeter is 64. What is the perimeter of this drawing? What is the perimeter?
16.
2, 4, 6, 8. 8 plus 8 is?
16.
So the perimeter, this is my actual perimeter, and this is the drawing perimeter. How do I find the scale factor? How do I find the scale factor? What's 64 divided by 16? What's 64 divided by 16?
8.
4.
Wait, 4.
I did that in my head.
Okay? Watch. 64 divided by 16 is 4. So what that means is this. My actual dimensions is 4 times as big as this. So what's 2 times 4?
8.
This side is 8. Hold on just a minute. Let me redraw this out. Okay, 2 times 4 is 8. 2 times 4 is 8. 2 times 4 is 8. 4 times 4 is 16. 4 times 4 is 16. So this is my actual building. I went from here to here by multiplying by the scale factor. Okay? Now, I'm going to my new drawing. It's a drawing, so I'm going from the actual to my new. So what do I do with my scale factor?
Multiply. By 8. Multiply by 8.
So, freeze frame, let's go back and read.
Wait, no.
What is the new drawing if the scale factor is 2 feet to 1 inch? So that means every 2 feet on here is 1 inch on here. So what do?
Divided by 4.
I'm going to divide by my scale factor. What's my scale factor? 2. So 8 divided by 2 is 4. 8 divided by 2 is 4. 4, 4. 16 divided by 2 is 8. 16 divided by 2 is 8. So this is what my new drawing looks like. Okay? And what I did is I found my scale factor and I multiplied my drawing by my scale factor to get the actual dimensions. Then in the problem it told me what my new scale factor was. So I divided by that new scale factor to get my new dimensions. Make sure that you go through your book, go through your notes, especially lesson number 6, because that's a lesson that we did recently that we might not be as prepared for. Be ready for your Unit